Imagine you are floating in space. Just you. No ship, no suit, just silence and stars in every direction. And somewhere ahead of you, there is something you cannot see. No light coming off it, no color, no shape, just a region of space where everything around it bends, warps, and disappears. A black hole, and you are drifting straight toward it. So, what actually happens? Do you get ripped apart? Do you burn? Do you even feel anything at all? The answer is one of the strangest things science has ever produced, and it does not work the way you think it does, not even close. First, let us talk about what a black hole actually is, because most people have the wrong picture in their head. It is not a giant vacuum cleaner sucking everything in. It is not a hole in space like a tunnel. It is an almost unimaginable amount of mass, the remains of a dead star, crushed down to a single point so small it has no size at all. And the gravity that produces is so extreme that not even light can move fast enough to escape it. That is the key thing to understand. Light travels at 300,000 kilometers per second, and even that is not fast enough. If light cannot escape, nothing can. There is a boundary around a black hole called the event horizon. Think of it as the point of no return. Cross that line, and every direction you can possibly travel leads deeper in. There is no longer a direction called away. Every path forward, backward, sideways, all of them point toward the center, and you are still drifting toward it. Here's the first thing that will surprise you. When you cross the event horizon, that invisible point of no return, you will not feel it. No alarm, no wall, no burning. If the black hole is large enough, you could drift across that line and have absolutely no idea it happened. The stars still look normal, space still surrounds you, nothing feels different. And then, slowly, something starts to change. The light around you begins to bend. Stars that should be behind you start appearing in front of you, pulled around the black hole's gravity like light curving through a glass lens. The universe around you starts compressing into a shrinking ring above your head. Everything outside, every star, every galaxy, all of it squeezed into a tiny glowing circle, getting smaller and smaller the deeper you fall. But here's where it gets really interesting. The people watching you from outside, they're seeing something completely different. To someone watching from a safe distance, your fall would appear to slow down and slow down and slow down some more. You would never appear to cross the event horizon at all. From outside, you would seem to hover just above it, gradually fading, gradually redshifting, frozen in place, suspended at the edge for what looks like billions of years. Two completely different experiences of the exact same moment. You crossing in an instant, them watching you freeze forever. That is not a movie effect. That is what the physics actually says. Gravity bends time. The stronger the gravity, the slower time moves, and near a black hole, the effect is not subtle, it is total. We actually use this in real life. GPS satellites orbit Earth far from its surface where gravity is slightly weaker. Time passes faster up there than it does on the ground. If we did not correct for that difference, your GPS would be off by kilometers every single day. Now scale that effect up to a black hole. By the time you reach the center, trillions of years may have passed outside. The stars you looked up at your whole life may already be dead. The universe you came from may be almost unrecognizable. You fell in, and everything else moved on without you. But let us talk about what is actually happening to your body, because this is the part nobody wants to think about. As you fall, the gravity pulling on your feet, assuming you go in feet first, is stronger than the gravity pulling on your head. Because your feet are closer to the center, even by just a small distance, the difference in gravitational pull is enormous, so your body starts to stretch vertically while simultaneously being squeezed in from the sides, longer and thinner, until you are not a person anymore. You are a long, thin stream of particles stretched across thousands of kilometers, falling toward the center. Scientists actually gave this a name, spaghettification. That is the real term, not a joke, published in peer-reviewed physics papers. Spaghettification. Now, whether this happens quickly or slowly depends on the size of the black hole. A small one, formed from a single dead star, would start tearing you apart before you even cross the event horizon. A supermassive one, the kind at the center of a galaxy with millions or billions of times the mass of our sun, would let you cross the event horizon gently and only start pulling you apart much deeper in. Different black hole, different experience, same outcome. And at the center of all of this is something called the singularity. This is where every piece of matter that has ever fallen into the black hole ends up, compressed down to a single point of zero size and infinite density. Infinite density. Here's the honest truth about what the singularity actually is. We do not know. When physicists apply our best equations to the singularity, the math breaks down completely. It produces infinities, numbers that make no physical sense. Our understanding of reality simply stops working at that point. Most physicists believe the singularity is not actually a point of infinite density. They think it is a sign that our understanding of physics is incomplete, that something is happening at those extremes that we do not yet have the tools to describe. What is actually at the center of a black hole? We genuinely have no idea, but here is the part that really does not let go. Physics has a rule, one of its deepest and most fundamental rules. Information cannot be destroyed. Every particle in the universe carries information about what it is, where it has been, what it has done, and that information, according to everything we know, has to be preserved somewhere. It can be scrambled, it can be transformed, but it cannot simply cease to exist. Black holes seem to break that rule. Stephen Hawking discovered that black holes slowly lose energy over time, radiating it away in tiny amounts through a process now called Hawking radiation. That means black holes are not actually permanent. Given an almost incomprehensibly long time, they will shrink and eventually evaporate completely. And when a black hole evaporates, when it is completely gone, what happens to everything that fell in? All the stars, the planets, the people, every piece of information that made those things what they were? If the Hawking radiation carries none of that information and it appears it does not, then when the black hole is gone, that information just disappears, which should be impossible. This is the black hole information paradox, and it has never been solved. Hawking spent decades wrestling with it. The greatest minds in theoretical physics have proposed solutions, some of them so strange they barely sound like science anymore. None have been proven. The black hole swallowed the information, and nobody can figure out where it went. Now, here's something that should make all of this feel a little more real. Black holes are not theoretical anymore. We have seen one. In 2019, the Event Horizon Telescope, a network of radio telescopes spread across the entire planet working together as a single massive instrument, captured the first ever image of a black hole. The supermassive one at the center of a galaxy called M87, over 53 million light years away. And then in 2022, they did it again, this time photographing Sagittarius A star, the black hole at the center of our own galaxy. 4 million times the mass of our sun, 26,000 light years from Earth, sitting at the center of the Milky Way with every single star in the galaxy, including ours, orbiting around it. It has been there the whole time, long before humans existed, long before Earth existed, the center of everything we call home, and it is a black hole. It is not a threat to us. We are nowhere near it, but it is real and it is there, and we can now take pictures of it. So you started this floating in space, drifting towards something you could not see. And now you know what would have happened. You would have crossed a line that felt like nothing. You would have watched the entire universe compress into a shrinking ring above your head. You would have been stretched into a stream of particles by forces no human body was ever built to survive. And at the center, you would have reached a place where our best understanding of the universe just stops working. But here is the thing: according to physics, you cannot simply be destroyed. The information that made you, every particle, every atom, every piece of what you are, cannot just cease to exist. The universe does not work that way. So, where does it go? That is not a philosophical question. That is an open, unsolved problem in physics, one of the biggest ones we have. And until we figure it out, there is a version of this story we simply cannot finish.